Everyone, so today I'm going to teach you a little bit about binary search, which is a really efficient way of checking a sorted list. It has to be sorted to see if an element exists there. And you can return either the element or what index it's at, and you just know it's there or it's not there. And you can potentially know if it's not there where it should have been if it were in there, or if you were to insert it, what index it would be at. So the first thing you do in binary search is you have an array and it has to be sorted. And you first look at your left index, which is usually going to be index 0, and you look at your right index, which is index 6. And then you find your middle, which is, in Java at least, you can always do left plus right divided by 2, which in this case gives us 3. But in some other languages, like JavaScript, for example, you have to take the floor of it, so you have to truncate. So for example, if right was 7 and left was 0, you'd say 7 divided by 2 is 3, because although it equals 3.5, you truncate it down to 3. So say we're looking for 11, which lives at index 5, and the first thing we're going to do is we're going to look at the middle index. So we're going to look at element index 3, which has the value 8. And we're going to compare 8 to 11. So we say obviously 11 is bigger than 8. So we know that the value we're looking for has to be to the right of this value. So we can say that now we can move our left to 4. And our right will still remain 6. And then our middle becomes 5. Left plus right divided by 2. So we know it has to be in the range of 4 to 6. So it has to be somewhere, one of these three numbers. So we look at our middle again. We see it's 11. So we compare 11 to what we're looking for is 11, and we're done. We can return middle, which is the index that it lives at. So say instead we were looking for 15, and or let's say 12 actually. So we're looking for 12. So our first steps would still be the same. We'd know it'd have to be in the range from element 4 to 6. So it still has to live in here. But you'll notice that 12 doesn't exist among these three elements. So we'll look at 11 and we'll say, well, 11's less than 12. So we're going to we know it has to be after 11. So we'll set our left equal to middle plus 1. Because we know it's not in this index, so we know it has to be to the right of it. So we'll set our left equal to 6, our right still equals 6, and our middle will thus equal 6. So we're looking at element 6, we see 15. 15 is bigger than 12, so we know it has to be to the left of it. And when things are to the left of it, we set our right equal to middle minus 1. So we'll set our right equal to 5. Our left remains 6. And even before we figure out what middle equals, you'll notice there's a problem. So it has to be, the leftmost index it can be is 6, and the rightmost index it can be is 5. So that would be like, we're saying it looks like something like this or something. Like it just can't exist. Like, so it's a problem, right? The left value is means it has to be either at this value or to the right of it, so it would have to be at 6 or to the right of 6. And the right value says it would have to be either at element 5 or to the left of it. So we're a problem, we're done. But you'll notice this number should be at element 6, which is the value of left. And this time right was changed. Say we were looking instead for 10. So we're looking for 10. So if we're looking for 10, we can just go through the whole thing again. So first, we look at element 3. We say 10 is bigger than what's here, so we know we have to look to the right of here. So we'll set our left equal to middle plus 1, which is 4. We'll set our right still the same, 6, and our middle is 5. So now we're looking at element 5, which is 11. 11 is bigger than 10, so we know it has to be to the left of it. So we'll say our right bound is now 5. Excuse me. Our right bound is now 4, which is equal to middle minus 1 because we know it has to be to the left of here, and the index to the left of 5 is 4. So our left and right are both 4 now. Our middle is 4. And we look at index 4, we see 9. 9 is less than 10. So we know it has to be to the right of it. 10 would have to be to the right of 9. And so we want to set our left bound equal to middle plus 1. We want to set it to the, if we know it has to be after index 4, we want to start looking, or set our left bound to the first index after 4, which is 5. But our right remains 4. Only one of these will change every time, not both. And even before we count our middle, we see there's a problem. And you'll notice this time, we still return left. So we know 10 should be where 11 is. So we're always returning left if we want to return where an index should be. So let's hop over to the code. So I created an array, has 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in it. And I have a value that we're looking for. We'll say looking for 4. And we'll binary search it, and then we'll print it out. The value for should be at index. So our binary search. So like I said earlier, the first thing we do is set our left bound to 0 and our right bound to the last index in the array. And then we're going to create our middle variable. But we don't need to initialize it quite yet because we're always going to initialize it in this while loop, so it would be a little bit redundant. So we're going to say while left is less than or equal to the right, because if the indexes it could be from would be like from left to right, and if left is bigger than right, well, there's a problem. So we set our middle as the average of the two, and then we compare our middle to target, and the target's the value we're looking for. So if the number in the middle is equal to the target, we'll return it. Else, if the number we're looking for is less than the target, then we know it has to be to the right of the target. So if the target, what we're looking for, comes after where we're at, we only want to look at the numbers after what we're at. So we'll set our left equal to our middle plus 1. Else, if the number we're looking for is less than the number we're at, we know it comes before wherever we are in the list, so we'll move our right bound to where we're at minus 1. And this while loop, it will either return here, if you find it, or it'll return left. So left is always where what you return if you want to return what index it should be at. So we'll run this. We'll look for 1, and 1 should be at index number 1. So we'll run it, and the value 1 should be at index 1. Let's look for maybe 5. So there's 4 different 5s. So let's see what will happen. So it says index 4, 0, 1, 2, 3, 4. So it says it found it here. Why don't you think it found it like at index 5 or 6 or even 3. Well, you'll notice there's 9 elements in the array, and that means right will equal 9 minus 1. So our middle will equal 8 left, which is 0, plus right, which is 8, divided by 2 is 4. And it'll search for numbers of 4, and it'll find it. And it'll return 4. So 0, 1, 2, 3, 4. So it returns 4 instead of 3, 5, or 6. Sorry, I think I might have messed that up earlier. But yeah, it'll return that. So let's see if what happens if we look for 66. So 66 isn't in our array. It should be at the last. If we insert it, it should come after 62, which means it should be at index 9. So run this, and index 9. So in our last search, we searched for 62. We said it should be to the right of 62, and when it's to the right, we move our left bound. So this is when left got changed, and that caused this while loop to break. So if we look for negative 12, the last search it'll look at is negative 10. It'll say, well, what we're looking for comes before it. So it'll move the right bound over, so it'll set right equal to middle minus 1. And you'll notice, should say 0, yeah. So either way, regardless of whether either of these two statements gets executed before it returns, it works. So you'll get the correct value. So what happens if this array is not sorted? So go like 12, 55, 15, 25, negative 5, 12, 12, negative 12, and let's look for 10. So it found it. That was pretty good. The first number it looked at was 25. It says to the left of it. It looked at 55. It said to the left of it, and then it looked at 10. So it found it. Let's look for 12. So 12 said it should be at index 2. It didn't find it, even though it's in here. Because what happened is the first, it looked at the middle one, which is 25. It says 12 is less than 25, so it has to be one of these numbers. It looked at 10, said, well, 12 is bigger than 10, so it has to be one of these numbers. Then it looked at 55, said 55 is bigger than 12, so it should be here. So yeah, which would be index 2. So that's it. I hope you guys got a decent understanding of binary search, and thanks for watching.